Okay, I hope there's people watching. I have no idea. Okay, I hope there's people watching. I have no idea. Okay, I hope. There we are. Cool. So I'm a DevTools user, not a truffle, hard hat, brownie. So if you want to follow along with DevTools, so you need to install Nix. I'll do another video of this. After you install Nix, you want to download DevTools. So git clone DevHub, DevTools, maybe recursive, right? So once you have that, you go to DevTools and you need to install the 4 packages that I like. Nix. So yeah, Nix environment, install HEVM, dap, seth, eth sign. This is not needed, but okay. And F I think is for follow, and path. So you will have seth and dap. And that's it. Let's get started. We're gonna do a simple ERC20 token, and then maybe we're gonna debug some of it and look at some of the underlying bytecode. So have my dgen folder where I do cool stuff. So let's do directory token if we don't have one yet. Yeah. So token, and we're gonna create a dap project. So if we do dap, and make this a little bit bigger. So if we do dap version, you'll see that the version that solc that comes is 0.6.7, and there are ways to get other versions working, and that'll auto download. But there's also this variable, I think it is dap solc, and you can point it to a local solc file, which is what I'm gonna do. And if I now use that version, says, yeah, 084, which is the one that we want. And so we're gonna go dap init, and that created something for me, and we'll go over what it is. So let's open Visual Studio Code, make it bigger. We have a makefile. We're not going to be using this. We have the token and a test for the token. So let's fix just a couple of things. First one, let's go 8.4 and 8.4 here as well. And maybe we can use this here. So dap solc build, and we're gonna fix this real quick because I don't like those warnings. Oh, what? MIT? Let's go with MIT. This one. MIT as well. Dap build. We're good. Okay. And you can see the output dap solc. So this is everything that comes from this. There's a whole bunch of stuff, but we don't need to know too much about this. Okay, so what do we want to do today? We want to create a simple ERC20 token and maybe do a couple of tests. And like I said, maybe debug some of it. And there are 2 things that I really want to go over, and this is optimized versus non-optimized. Let's see if solc does something, you know, for memoizing variables, how many S loads. Maybe that's it. I don't know. It's midnight here in Buenos Aires, so probably won't have a lot of time for this. So let's do contract, what do I want to call it? Let's call it, yeah. So what does an ERC20 have? Has a name, symbol, decimals. And it's been so long since I programmed, I'm gonna mess up the solidity so much. I don't even remember what goes first. So like constant, public, I don't know, but we'll figure it out. String constant, maybe, public, name, and we'll call it and I want to try this out because token, oh, right. Now let's change this up so it's this is CXX and this as well, right? Good. And because I don't want to be typing all of this all the time, what I'm gonna do is I'm gonna create a test.sh. I'm gonna make this executable and so user bin and bash, gonna export tabsolc and what else? Dap has a whole bunch of variables and you can find them maybe in the README. So optimize build, let's set it to 0 for now because we don't want it optimized. We will later. Optimize build runs, I think. And when we want it, we're gonna go 999,999 because Martin Lundfall told me to go as high as you can, and I trust the guy, one of the smartest people I know in Ethereum, so we're gonna do that. And the build, so we can do test. Perfect. Okay, so maybe this is not gonna be a speed run, but we'll see. So we have a name and symbol. That's going to be a symbol. Oh, we said XX, so yeah. And decimals. Decimals are U8, right? Everything should be constant, public, decimals 18. Good. Okay. What else is in an ERC20? And shit, I shouldn't be doing this, but I'm gonna see if there's actually people watching or not, because 13 people. That's good. Somebody said you are mute. I hope that I'm not. So so this here says mic auxiliary. You're not. Okay, thank you. Okay. Back to it. What does an ERC20 token require? A total supply first. So let's start with the basics. It's going to be constant supply as well. Constant public. And if I'm not mistaken, it's like this. Total supply. Let's have maker started with 1 million, which was a bad idea. So let's do 100 million. And we can do either ether, which I prefer, or people like doing this one. Either way. So we have a total supply of 100 million. And we can start testing this, right? we can go to the test, and we're going to remove the failing test and test total supply. And after we create the token, we're gonna assert equal. Let's do this. CXX, the total supply is equal to 100. Cool. And our test, which was that build, we're gonna change it to that test, and let's say verbosity 1. Let's see how we do here. So it passes, that is good. Verbosity 2, what does it do? Verbosity 3. Okay, this is more like it. So calls the setup, creates a token, and then total supply, calls total supply and receives this, and set from way this, and you can see, right, 100 million, perfect. Okay, so we have total supply. What else? So a token has balances, right? So when I'm mapping, I don't even remember how, yeah, mapping address to U256, public here, maybe. Balance off. That looks okay. Okay. And well, while we're at it, but I'm not gonna deal with this till later. But we want a second mapping for allowance. So it's a mapping from address to another mapping, right? Spender, spendee, or whatever it's called, recipient, and the allowance. And what is this? Public. Identifier, oh, yeah. Allowances. Really, it's been so long, I have no idea. A lot of people sent me code yesterday. I ended up not reading it just to see if I could remember from memory. So this is going to be one of the first. Allowance, approve. I don't know. We'll check later. Okay, so let's start with a simple one. Function transfer, right? That's normally the first thing that you do. You want to transfer. Well, before that, let's just do the, let's add a constructor. And I think in 8.4 you don't need the public. Let's do like this. We're gonna give everything to the message sender. So balance of message sender equals total supply. Maybe. Nope. Total supply. And I believe that the ERC20s from a while ago, they emit events. So a transfer event from an address to an address and an amount, and it's not emit, it's event. Yeah, it has been a while, and this should be indexed, and this one as well. Let's see. Yeah, everything good so far. So it's a total supply, and then we emit transfer event from the address 0 to the message sender of total supply. And in this case, we're all good because total supply is constant. This and this will, we'll come to this when we get there, but maybe if we change it later. We don't need, let's not do this now. Cool, let's do a transfer. So function transfer to somebody and an amount and external, and very important, yeah, transfer events return bool unless you're OMG and maybe some other token. And one thing I want to remember is, and this is where there are so many ways to do this, and I actually at some point want to check the gas for all of this. So external is cheaper, right? Externals is always cheaper, maybe, because it grabs all of this from call data directly instead of from memory. But I've seen many of the ERC20 tokens have, transfer ends up calling transfer from. So every transfer is a transfer from. But then you cannot make transfer from external. You have to make it public. And then what does that do? You have, I want to test that. So test transfer from external or public. Have transfer, call transfer from, or not. We're gonna test those. Okay. So transfer, what do we need? So we need to check that the balance of message sender, right? So whoever's calling transfer has to be more or greater than or equal to the amount, or whatever, right? Insufficient amount. And then if message sender has enough balance, and this is one. So memorize balance of message sender. Or will the optimizer do it for us? That is a good one that I want to check. Okay, so if the message sender has enough balance, then balance of 2, does this work? Plus equal? I don't think I've ever used Solidity 8. So this already has solc 0.8, 0 maybe, has automatic over underflow checks. Nah, it does. So balance of 2 and balance of message sender. Does this matter? We'll see. So we check that there is enough amount. We give it to the to address. We take it from message sender. We emit, right? Transfer event from message.sender to the to address and an amount, and we return true. Like, I think that is pretty much it for a transfer function. Let's do a test. So, let's check the total supply as well. Assert equal balance of address this. So whoever creates, right, the token test is gonna be the message sender here. So balance of address this has to be equal to this as well. The total, let's total supply. And let's check. It is. Okay. And so let's try another one. Test transfer public. So transfer to, I don't know, the one address. Let's do one full token, right? So 1 with 18 decimals. And let's do it like this. Amount. Transfer. And then this address is going to have total supply minus the amount. And the 01 address is going to have that. Did it work? Oh, yeah, here it is. Test transfer. So when we create it, we do this one. And then when we call transfer, returns true. Balance of, it's one less, the other one. Okay, so far so good. Now I think I want to do something interesting. I want to see this, right? So this is reading from storage. This is an S load, right? Not this one, not this one. These are call data because it's external, but balance off, this is an S load, which is expensive, very expensive. It's one of the most expensive things that you can do. So how can we do this? Let's go back here and what was it? Test, export. Yeah, let's just, instead of test, let's do dab.debug. Let's see if this works. And so it's not optimized, right? And we can actually check this if we go to dab.json and and we find optimizer enabled false. Okay, so this is not optimized. Let's try it out. Nice. So this is dab.debug, and we're gonna test. I'm gonna do the transfer function. This is one of the most powerful tools that I know of. Let me see. Trace memory. Okay, it's been a while again. So Control N, we're gonna go past the setup, and we start. I wanna do the function dispatcher later, but let's see. Test transfer 1 ether, and as you can see, we're going over the bytecode. So push this is 1 to the 18th, and it's going to be pushed. If I go next, previous, next, you see that it's here on top of the stack. It is swapped, popped. Okay, there are many things. We want to go into the transfer function. So we're going to see a whole bunch of stuff. This is non-optimized compiler code. And we want to see the gas and the call, which jumps to the other contract, right? Because we're in the test contract, and we want to jump to the token contract. Wow, I have no idea what all of this is doing, but it is a whole bunch of code. Okay, we're getting close. You see, Solidity does an Xcode size to see that the contract that we're calling exists, right? So it returns this 1995 bytes. That's the size of the CXX token. Checks that you know, it is not 0. So pushes a whole bunch of things. Okay, the gas, right? It forwards all available gas. Here it is, all remaining gas, which is this, and call. So nice. Now we're in the CXX contract, as you can see. So this is all the function dispatcher, right? Call data size less than, call data load. Here we are. This is hopefully this should be transfer, right? It's gonna, yeah. So this is the catch-check of transfer address on uint56. So this is the function that you want to load. So which one is this? So this is the one. This is the one that it has. This is the one that it's checking first. So is this function is what we want balance off? No. So continues. Is this, are we asking for symbol? So also this is important if you really want to optimize. Like I would say that maybe transfer is the function that is most used. So maybe you would like to have it first, you know, in the dispatcher. I don't know. So are we asking for the symbol? No. Are we asking for the transfer? Here we are. Yes. Right? 1. So it is equal. So we jump to 298, which is 12a. And as you can see, we're here in 4b, the instruction. And it says jump to whatever is at the top of the stack, which is 12a. So when we jump, you see that this is 12A, the jump destination. Nice. And we can see down here that this is transfer. So let's see. What we want to check is the number of S loads, right? So call data size, all good. So many, wow. Call data load. What else? Anything interesting here? Again, I have no idea what all of this is. Just N to go forward. At some point, we should. Wow, okay, finally, we're here, right? You can see this is caller, right? This is the message sender. It's put on top of the stack. This is message sender is actually the address of the token test. If you hit enter, you can see token, that's the token test. Here we are, that's B4C7. Escape, B4C7, good. What else? The amount, okay, that is not really important. That's, we're gonna get it from call data, so it's all good. Oh, okay, balance. Wait, did we already do the S load? Oh, yeah, here we are, good. Okay, so this is the important one. We want to check that the balance of message sender is greater than or equal to the amount. So we need to load the balance. We need to do an S load, right? And we're doing an S load. This catch-ack, this is like the way Solidity, what do you say it? It's like the way it compresses the slots so it can, you know, put the mappings somewhere. And we do one S load, right? And gonna go again, previous. When it does the S load, this is what we get. We get that the entire balance belongs to this address. So this is correct. What we want to see if it happens again is that if this message sender, balance of message sender, if we get another S load here, which wouldn't be great because we're calling twice something that we shouldn't. So we continue, balance of 2. This should be an S store because we're storing the amount at some point. And I want to go over some of this code. And here we are, right? So the S store, it's gonna store in this location this. Okay, so it's gonna store this, the 1. And good, it did it. If we go with M, I don't know if this works. Yeah, let's not bother with this right now. And this is the important one. Let's see, balance of message sender. Let's see if this does, and yeah, here we are, see? So this is a second S load. Completely unnecessary. We already had balance of message sender with 1 S load, and now we're doing a second one, wasting valuable gas. This is what we're gonna do. We're just gonna continue and we're gonna end the test. And we're just gonna try it again with optimizations. This is gonna build, hopefully optimized. Let's double check. optimizer enabled false. Huh. This is the part that optimize build. Damn. Yeah, I have no idea what I'm doing here now. Did this work? Optimizer enabled false. Shit. Dap optimize something. Ah, okay. Let me try. Maybe it's something else because I can never remember this. Okay. This was easy. So it's not optimize build, it's build optimize, which is not bad. So we're gonna build optimize. Easy. So let's try it again. We build this and we go here and we search for optimizer enable true runs perfect. We don't want this, we want this. And let's try it again. We're gonna go faster this time. Let's try the transfer function. And well, I should have checked if there was actually more, yeah, or less code. There should be less. And this is the dispatcher again, checks for balance of first, well, then symbol, then transfer. It is, it jumps, yeah, already it's a different jump destination, so we're good. And let's see about those S loads. Already I can see that there is less code, right? Less bytecode instructions, I believe. And store, we get to the S load. Okay. So this S load, yeah, the the slot where it's gonna read from. We got this. This is good. And well, this is interesting. Oh no, I thought it was gonna be something else. No. Okay, let's continue. Another S load. This is okay. This is the balance of 2. But already seeing that this remains makes me hopeful. Okay, so we add 2 and then balance of message sender. So it saves, then pop, caller, what? Seriously? Another S load? Wow. Damn. This is, unless I'm doing something wrong, I really thought that, thought that the compiler would be smarter than that, but I don't know. I guess either I'm doing something wrong or compiler's not smart enough. Weird. Okay. Damn. Okay, so it's 30 minutes past midnight, and I couldn't actually do a speed run, but we got what? This. What are we missing? And we need to find if this is correct. We're missing the approved, we're missing the transfer from, and I think, well, you know, the approved event, I think that's all that's needed for very simple ERC20. So I'm gonna do that tomorrow if there's enough interest. Then we can do maybe mint and burn and whatever else. And we're gonna go over some of the bytecode again, because I seriously cannot believe that unless I'm doing something very, very wrong, which I'm pretty sure that I'm not, because this does the build. So let me test this again. So I'm gonna clean this, I'm gonna rebuild it, and I want to see here if it's actually optimized. Enable true runs. So what is going on? Let's do one last thing. So let's do address of sender equals this. So let's cut this and say the sender, whoops, what, have two cursors. There we go. What is this? Type, oh, right. It's not the sender. What do I want to call this? Initial balance. Let's leave it at that. So the sender balance is the balance of message sender. We require that it's greater than or equal to the amount. We add to one and we remove from one from the other. Okay. And let's see if that does anything. Let's test the transfer. See if it does anything to the, here we are. Transfer. Okay, trying to find. Okay, so, caller. Here's the S load, right? One S load. So now sender, the balance of message sender, was already read from the state. And then we should not have. The only other S load we should have is the one for the to amount. And we store it here, and we don't need to read the balance of the sender anymore because we have it, right? Yeah, there was no, wait. Was there an S store? I'm falling asleep here. I'm going back up. Oh, yeah. No, and from the sender. This is no good, right? Because this is in memory. Wow, this is a big bug. Oh man, I'm so glad that I don't do smart contracts anymore. So what do we have to do? Storage? Yeah, you know what's happening here? I'm grabbing the balance of message sender. I check that it is more. I store this, but this is just a variable in memory. And this is like a big bug. Wow. So glad that nobody's watching. Okay, so we're gonna fix this tomorrow. For now, I wanna leave it in, you know, decent state. So I'm gonna do this and this and this. And yeah, that's it. It's 20 minutes to 1 a.m. So hope you enjoyed it. We're gonna keep it up tomorrow. Bye-bye.